In this video, I wanted to do an example with you where we look a little bit deeper at exponential equations and remind ourselves that just because now we know how to solve exponential equations doesn't mean that we've forgotten how to use other techniques for solving equations. Both of these are problems from your homework. Of course, you might have slightly different versions of them, so you'll see, for example, there's stuff in red here, right? The 8, the 4s, the 3. So those are going to be different in your version, but it's going to be a very similar problem. So you're supposed to solve this equation. This is an exponential equation because there's exponentials in it. But I want you to notice that in addition to being an exponential equation, there's also some factoring we can do. So in particular, notice that in the expression on the left-hand side, there's a greatest common factor. All of the terms are divisible both by x to the fourth and e to the power negative 4x. So just like we've done in the past, we can factor the GCF out. So let's do that. Okay. So what we have is, remember, when you're factoring out the GCF, you're thinking about what would you multiply by each term to end up with what you started. What would you end up by x to the fourth e to the negative 4x to end up with what you started? So the first term would be 8, right? So again, you're dividing out that x to the fourth e to the power negative 4x. And the second term would be minus 3x. Okay, so that's going to be 0. And so now you've got the product of things equaling to 0. So this is where we remember the zero product property. And I'll remind you of it here that if two things multiply to 0, then either the one or the other of them must be 0. Okay? So looking here, we can break it down into two pieces. We can say, well, if these two things multiply to be 0, then either 8 minus 3x is 0, or x to the fourth e to the power negative 4x is 0. And with the one on the left, you can almost break it down one step further. You can say, well, if that's 0, then either e to the power negative 4x is 0, or x to the fourth is 0. Doesn't really matter what order we approach this, so let's kind of start with this one here. So this is a linear equation, right? Like we can solve this in our sleep. We would subtract 8 from both sides and then divide both sides by negative 3. So we get negative 8/3. Now here we have sort of an interesting moment. So I'm going to sort of underline it in red. We're supposed to say, where is e to the power negative 4x going to be 0? Well, 0 is not in the range, right? If you think back to all of the conversations that we had about exponential functions, you'll remember that unless you've got some kind of vertical shift happening, you aren't, like, your graph is going to approach 0 without ever getting there. So it is not possible to raise the number e to any power and end up with 0. The same would have been true with a negative number. You can't take any number, raise it to a power, and end up with a negative. So in fact, this piece, e to the power negative 4x equals 0, does not contribute a solution. X to the fourth is 0 totally contributes a solution. If you want to ask when is x to the fourth 0, well, when x is 0. So in this case, we have two solutions, 0 and 8/3. So of course, if you'd like, you can check. So let's do that just to say we did. We'll get out our green color. So let's check. So if we plug 0 in for x, we get 8 times 0 to the fourth times e to the power 0 minus 3 times 0 to the fifth times e to the power 0. Well, sure enough, when you multiply anything by 0, you get 0. So sure enough, both of those pieces are going to be 0. And when you subtract them, you'll be 0. I'm going to actually encourage you to check 8/3 on your own. It seems like it would be more work to check 8/3 than it was to check 0, and it will be a little more, but you'll see that it goes very quickly. So I highly encourage you to do this in your own time just to make sure that you get, in fact, that 0 and 8/3 are both solutions. Just to wrap up this example, I'll kind of fill in the blank here, that the two solutions are 0 and 8/3. Now we move on to the other example, which is problem number 7, and I believe these are both homework number 14. So what I want to tell you here is I want to remind you of equations of quadratic type, right? Quadratic type equations are equations of the form a t squared plus bt plus c is equal to 0, where t can be anything. And you'll kind of see a little bit more of what I mean here. But what I'm talking about here is that this is the quadratic structure, okay? If you have some t, and again, t can be anything you want, if you have a constant times that t squared plus a constant times t plus another constant, and that's set equal to 0, that's an equation of quadratic type, which means that we can use what we know about solving quadratic equations to solve it. So check it out. I want you to note in this example that e to the power 2x is e to the power x squared. So in fact, and I'm going to do it in a different color. Let's do it in this purple. If we let t be e to the power x, and you'll notice a lot with quadratic type equations that we let t be the middle variable piece. It's not always going to work that makes the equation quadratic, but it's often going to work. So we have e to the power 2x, that's t squared, okay, minus 3t plus 2 is equal to 0. This is a quadratic equation. Not only is it a quadratic equation, it's one that we can use factoring on pretty nicely. T squared minus 2t plus 2 factors into t minus 1 times t minus 2. So the two options are that t is 2 or t is 1. Now, of course, and I specifically did this in purple to kind of remind us of this, we didn't come here looking for t. We need x, so we're going to convert back. Okay, well, t is e to the x, so we either want e to the x to be 2, or we want e to the x to be 1. So from here, you could use logarithmic form, so we're going to rewrite these in logarithmic form. Okay, so if we say that e is our base, x is our input here, and 1 is our output, in logarithmic form, this would be log base e, which is the natural log of 1, is equal to x. And I hope that you all remember back from our logarithmic properties days, the natural log of 1 is 0. Okay? All right, now let's look at this other one. So same thing, we're going to rewrite in logarithmic form. So e is our base, we can call that a. X is our input b. 2 is our output c. So in logarithmic form, it would be log base e, which we call natural log of c is equal to b. So x is the natural log of 2. Now, the natural log of 2 is an irrational number, so you could write a decimal approximation if you want. And in fact, you'll notice if you look here at the instructions in your homework, it says round your answer to 4 decimal places. And I'll let you do that on your own. You'll notice that when you input your answers, it's asking us for the smaller value to go here. 0 is the smaller of the two. And then the bigger one goes here, which is the natural log of 2. But when you do this problem on your own, make sure that you are rounding it to 4 decimal places to make sure that you're following the instructions. So this is the second of 2 videos that I'm going to do on exponential equations. And this video is just here to remind us that, in fact, just because we know how to solve exponential equations now, just because we know that technique, doesn't mean that we've forgotten all of the techniques that came before. So again, these are problems from homework 14, and you will see problems very similar to it when you go to do your own homework. Stay tuned for our last video of the week. See you soon. Bye.